Hi LinkedIn, it's Ali G. Today I'm going to talk about motor contactors. So I have one here. This one's Allen Bradley. So motor contactor. It's also called a motor starter. So this is actually how you just start a motor, or a way. There are other ways, but this is your more standard or traditional way, the older way to start motors is, it's also called, oh look, it's upside down, full voltage non-reversing, which just means that, when it's energized, there's a part that is energized, I'll show you in a second, that you are providing full voltage and you're not going to be doing anything with the phases or trying to reverse anything. So, when this is just an on-off, motor control. And how it works is there is a coil side and then a contact or dry contact side, and the coil side is actually this stuff up here. Point at it this way, it's better. So see, it's harder to see, but there's an A1 and A2, and so A1 is always like the hot side or the positive of the coil, and then the A2 is always neutral or common, or and you can actually take this apart and pull the coil side and turn it upside down so the contacts are underneath. I'll show you that in a second, but there are standard terminals on here for, this is for three-phase, so there's L1, L2, L3. The L side is the incoming side. You want to have the incoming power on the L side, and then the side that goes to the motor is the T side. So there's T terminals on the bottom of this thing. So you can't turn this thing upside down, but you can take and put this, remove this and put it, so that it's underneath, so that the coil is underneath. So you can wire it, the coil side on either side, but you have to do the plus of the three-phase power on the top and not the bottom. And what else? So there is where the actual coil is, there is a little metal loop that is holding all of this together. So you just take regular flat and kind of just push the loop up a little bit, there's no intense action here needed, and the whole thing will come apart. There is the same bottom loop. You gotta do the same thing to the bottom to take it apart. So there is a spring in here, to spring load the assembly together, but you can take this entire thing out and see that's actually part of the contacts, part of the coil, and then turn it around so now it's the other way, and put it all back the same, because there's still a top and a bottom, right? And actually, and make sure the spring is in there when you put it back together, or it won't spring return when it's off, and you want to be able to still bump these. Sorry. And then when you put it back together, I'll talk about something else. Not when I do. Okay, so anyway, there is a bottom clip in there and a top clip in there, and you do have to mess with those to take the whole thing apart. Remember to put the spring back in there. So now I have, I still have it the Allen Bradley, you can see, is still upright, but now the entire coil side is on the bottom. The A1, A2, where you turn on and off, the whole contactor is on the bottom. And then these top terminals are for the power, and then there's a third line for. So these either have a normally open or normally closed fourth terminal. That's why there's 4 on here, not the whole 3. But this one says normally open. So there is a normally open contact here that you can use to know when you can usually send that to your relay, or to your PLC, or to a light through a relay, whatever you want to do. Just to tell the operator that this motor is running. That's usually what it's also considered your auxiliary So you normally program that in your PLC as your underscore AUX, or usually you see auxiliary and they're talking about this contact on the starter when you're starting a motor with just a regular it's FVNR, full voltage non-reversing, versus, because you can have a VFD inverter, VFD, you can have soft starting, you can have Phoenix contacts, Contactron, which is like a hybrid motor starter, which mixes this with like a smart starter. But this is just like your on-off way to do basic starting, and you still have to protect this. Like, this is just the portion, to do the actual. This is the starter. There is other branch circuit protection that you should be using when you're putting these in for a line, and then how this is sized is actually by horsepower. So when you go to your motor and look at the motor specs, and the most important three things, actually, the three most important things on your motor itself, the motor nameplate, is horsepower, and then voltage, and then the full load amps. Because the full load amps are kind of just going to go with the horsepower. So when you get something like this, it has to have horsepower rating on it. If you can get these, they look like this, and they're just relays, and you're not supposed to be using that for starting any kind of motors. So if you're starting a motor, you need to look at motor nameplate, and then you need to buy a contactor with a horsepower rating that matches that. And then you look on there and make sure that it can take your voltage. This one can do up to 690 volts, but I would only ever use this one for 480. Or 230, three-phase. That's what we typically have in the US. And there's something called bumping a motor. I don't know if we're actually allowed to do that anymore, but there is a, finger safe contacts on here for you supposed to be able to like turn motors on and off with this. You should not touch it with your bare hands, even though you're supposed to be able to. Like, just don't. Sometimes I see kind of some arcing in there, so as you push this, like, maybe use a pen or a screwdriver. And you should be trained to be in front of like live 480, because if you don't know what it is, then you should not be anywhere near it. So this is, I guess a little bit more advanced, but when this is supposed to be finger safe, this part. And actually, when this coil, which is allowed to be on the top, remember, when this coil is energized, sorry. When it's energized, these will actually suck in, because that's actually like, making contact in there. That's why it's called a contactor. And because that relay, the coil is energized, actually pulling in this entire set of contacts. And that's why the power now is flowing through there when it's energized, and then when you lose that power, you lose that, and then the spring, basically pushes it open. That's why you have to have the spring in there, because if you lose the power, you still need to like spring return the contacts in here so that you stop the power flow through here, turning your motor off. I think that is enough for contactors today. Have a nice weekend.